You get to send something to space. Very few people ever even think of hearing those words, but here we are, and not only that, but my entire 8th grade class got to each send up an experiment to 100,000 feet on a high-altitude weather balloon and then study it as soon as it returned. It took a hot minute, but eventually, I ended up asking myself, how do the conditions of near space affect Sourdough Starter? I'm Wesley Freeberg, an 8th grader in Dimensions Academy at Olson Middle School. I'm going to walk you through the process and results of this experiment. To better understand the process of this project, we have to start from the beginning. So, what would I send to space? There were so many possibilities. What was unique? What would be interesting? What would be a fun experiment? You see, in near space, an experiment will be exposed to higher levels of radiation, drastic changes in temperature, extreme turbulence, and changes in air pressure. My first thought was, could I send up my own blood? A blood sample would contain living cells. What would happen to them? Would the radiation kill them? Would they freeze to death in the literally freezing temperatures of near space? And what about bacteria? Any blood sample left out without proper storage would experience bacteria growth, but would a sample exposed to radiation or freezing have less? Unfortunately, I never got the chance to find out, because a quick call to the American Red Cross shut down the idea of drawing vials of my blood just to have. No matter. I knew I wanted to send up something living, but the ever-restricting ethical quandaries of scientific research meant that I wouldn't be sending even a beetle anytime soon. I thought back to the idea of bacteria and microorganisms, and with the experience known unofficially as the Great 2020 Quarantine behind me, I began to formulate an idea. Sourdough Starter. It seemed that when we all had to isolate ourselves, we got bored, and as people discovered new ways to entertain themselves, just about everyone on the internet started growing these sourdough starters. Maybe it was just to experience fresh bread, or to learn something, occupy their minds, or maybe it was just to have another living thing to exist with. Whatever the reason, it seemed that the popularity of Sourdough Starter just skyrocketed. But the big question is, what is it? After some poking around, I learned that Sourdough Starter is essentially a symbiotic community of two microorganisms, wild yeast and lactic acid bacteria. Lactic acid bacteria, or lactobacillales, is a good bacteria that produces lactic and acetic acid. This, along with the gases produced by the yeast, gives sourdough its distinct tangy flavor and works as a leavening agent for the baked goods. Sourdough Starter is created by fermenting water and flour. That's it. The process gets slightly more complicated, but the basics are this. Using a ratio, often 1:1, of flour to warm water, the two ingredients are combined in a receptacle and left to sit in a warm place for about 24 hours. This process, only now with a 1:1:1 ratio of the starter to flour to warm water, is repeated for the next couple of days. During this time, the microorganisms begin to gather and reproduce, all the while producing their byproducts, fermenting and growing the sourdough starter. As soon as the starter starts to double in size between feedings, the process continues to be repeated, only now about every 12 hours. After, at minimum, a week of feedings, the sourdough starter is then ready to use in baked goods. When the time of the high-altitude balloon launch drew near, I followed these steps and created my own sourdough starter. There were a couple of issues that I encountered along the way. Most prevalently, a strong smell similar to vomit, which was most likely caused by an excess of butyric acid in the starter, but even that eventually dissipated. By the time of the launch, I was prepared to submit 2 capsules, a control and an experiment, each loaded with 15 grams of starter. Here was the basic hypothesis of the experiment. If exposed to near-space conditions, then the effectiveness of cultivated sourdough starter will be reduced. It sounds simple enough, right? There's an independent variable, which is exposure of sourdough starter to the conditions of near space. And there's a dependent variable, the effectiveness of sourdough starter as a leavening agent in baked goods, as well as the appearance and health of the sourdough starter. As basic as it may sound, there were a significant number of things that could have gone wrong, but before we get to that, let's talk about the results of the experiment itself. Okay, so I cultivated a sourdough starter, and I divvied up that starter into 2 equal capsules. One, a control, to be left on Earth and simply sit in a comfortable place, and the other, the experiment, a capsule sent up on the high-altitude weather balloon to 100,000 feet. 48 hours after first releasing the experiment capsule for the payload, our experiments were returned back to us. Upon preliminary examination, I noticed that there were no visible changes in either capsule, save for a thin layer of an opaque liquid which had collected over top and in equal amounts of both samples. Both samples then sat out at room temperature for another 4 days, as I had contracted COVID-19 and did not work on the project during that period. Nearly a week after first releasing the capsules, I baked a very small amount of sourdough bread, following a simple recipe that used sourdough starter, flour, salt, olive oil, and water. I created 2 identical batches, with 1 deviation. Each batch used a separate starter. One batch was created using the control starter, and the other, the experiment starter, which had been sent up on the weather balloon. As I was baking, I noticed a couple of other differences. Number 1. The control starter had a stronger smell of alcohol or fermentation, and the experiment was not only less so, but had returned to a slight vomit smell. Number 2. Neither dough sample rose whatsoever. Even after being left to rise overnight, the starter and the dough did not increase in size. Number 3. During and after baking, the mixture once again did not increase in size by any amount, and its volume remained identical to that of the dough that was first created. There's a bit of speculation as to what went wrong. My best guess is that one of 2 or both of the following occurred. Number 1, the sourdough starter wasn't ready. Though I should have properly timed the creation of the sourdough starter properly with the balloon launch, it's possible that the presence of butyric acid and its accompanying vomit smell set the starter back in its development. That would mean that the final starter wasn't fully cultivated and wouldn't serve as a substantial leavening agent. Number 2. The second explanation I've considered is that the starter simply died out. Between the rapid changes in conditions, the long period without feedings, and lack of proper care, I see it being quite likely that the community just died, leaving no microorganisms to do their thing. This result was the same in both the control and the experiment batch. For that reason, I have to declare the results of this experiment inconclusive. But there was much learned throughout the entire experiment. I learned from scratch how to cultivate a sourdough starter, and I learned just what it is and how it works. If I got to do the experiment again, a number of things would happen. Number 1, I would start the sourdough starter weeks earlier. Once sourdough starter is properly cultivated, it keeps in the fridge indefinitely as long as it gets weekly feedings. So I could have prepared it in advance and then reactivated it when it was time for the project. Number 2, I would act immediately. Now, obviously, I wasn't expecting to be knocked out for a couple of days with COVID, but I really should have pushed through and baked the batches of bread as soon as I could. I do believe the result of this experiment would have been different if the starter hadn't been given a chance to die. Finally, given the assumption that I would be allotted more weight or space for my project, I would have liked to increase the amount of sourdough starter in each capsule. Otherwise, the resulting batches of bread would have been considered minuscule. This truly was a fantastic experience, and even though the experiment was inconclusive, it was a ton of fun, and I would welcome the opportunity to do it again anytime. Thank you for listening. I have been Wesley Freeberg, and this has been How Do the Conditions of Near Space Affect Sourdough Starter? This podcast was created in collaboration with Sean Hildebrandt, Katie and Dan Freeberg, and Olsen DA. Tools used throughout the episode include Audacity, Descript, and Anchor.